Momentum. 1. Introduction. Alright, in this section we're going to look at the physics quantity called momentum. We're going to look at it in context of explosions, collisions and crashes, but from a physics viewpoint. So we're not going to blow anything apart with dynamite, and we're not going to crash cars together and things like that. So just calm down. It's going to be not as exciting as you think it might be, but if you're into physics it will be quite exciting, sort of. However, it does have real life applications, and so this guy, you may have seen people breaking bricks with in this case your elbow and their hands, and some people are foolish enough to even try and do it with their heads, and you'll learn hopefully in this section that it's really just physics, and it doesn't require superhuman strength. It requires a little bit of courage to actually do it, but there's a few tricks involved in how they do it. And particularly if you watch all these pictures, here's someone else doing it, and if you watch this video on the OneNote, there's a couple of videos, you'll always see that all these bricks are always not real thick, if they're breaking tiles, bricks or wood, and they always put a space between them. And so basically the trick is, if you have the strength to break one of them, you can break all of them, because the force that you exert on one to break it is enough to break them all, because it's actually you're using momentum to apply. And I think there's on the OneNote one guy, or maybe it was on YouTube, he was breaking 43 tiles or something, and you could see on the video he breaks the first couple, which is not too hard because tiles are pretty brittle. Same with these concrete things, they're fairly brittle in reality, and then the whole pile just collapses without him actually doing anything else, because the weight of these guys are actually pushing and breaking this guy down here. And so there's no superhuman ability in breaking these things, but it looks impressive. And if you didn't know physics, you might be fooled into thinking that you've got to train for 12 years to be able to do this. So what is momentum in terms of physics? Well, momentum is the product of mass and velocity. So it's the sum of mass and velocity, and so there's momentum equals mass times velocity, and our formula for it is P equals mv, where P is the momentum, little p that is, not capital P safe for power, and the unit of momentum is kilograms meters per second, and that comes because this is mass in kilograms and this is velocity in meters per second, times those together, and there's our unit, you see. Now the direction of momentum is always in the same direction as the velocity, so it is a vector quantity, and so if we have a direction to the velocity, we have a direction to the momentum. Change in momentum is what we're going to look at a lot, and it doesn't stay the same, but it changes as velocity changes. And so the change in momentum is equal to the final momentum minus the initial momentum, very similar to change in velocity. So the change in momentum equals final momentum minus initial momentum. What does that look like in a formula? Delta P, change in momentum, equals momentum with a subscript F for final minus momentum with a subscript I for initial, and recognizing that P equals mv, therefore this would be mass times final velocity minus mass times initial velocity. Yep, and that's where they all fit in. So final velocity and initial velocity, and if we've got the mass, we can work out the change in momentum. Notice that this isn't on the information sheet. You're expected to be able to deduce this from your understanding. I hope you can. Let's look at an example. Calculate the momentum of a 2 kilogram bowling ball travelling at 8 meters per second south. Pretty interesting. All you have to do is P equals mv, use the correct units, so mass 2 kilograms, 8 meters per second, 16 kilogram meters per second south, same direction as the velocity. Another example, a bit more out of this world, or more of this world, but not within our perception. A photon of mass 1.67 times by 10 to the minus 27 kilograms is accelerated from 3 times by 10 to the 4 meters per second north to 3 times by 10 to the 5 meters per second north. Calculate the change in momentum. So we're given a mass, we're given an initial velocity and a final velocity. So we would put it into this formula here, working out our final momentum and our initial momentum. Of course, we're after the change in momentum. It's the difference. So here they've done the calculation for you. I, being a model student, would try to, or recommend that we put this and this, when we write these, we put them in brackets just to make sure that we're using correct. And when we're doing this, we're using our EXP button on our calculator, and that way we keep these together. So that was going to be our final momentum and our initial momentum. Very similar calculation, but using a different power to the velocity. And then we change the momentum, we subtract the final, subtracting the initial from the final, and we get our answer. Okay, let's get rid of that writing, that's in the way. So now you should be able to do questions 3 and 4 in your OneNotes or the notes that I've given you when you're ready. And in the next video we'll be looking at what's called impulse and how momentum relates to forces. See ya.